Welcome to lesson 36 of our interactive notes. Today, if you have something like colored pencils or crayons that you could use, go ahead and get them out. If not, if you have highlighters and different color pens and pencil, that can work as well. So just something that has like a different look or a different color will help in today's lesson. So we're on part 1 of lesson 36, and that is decomposing fractions, and that's going to be on pages 19 and 20. All right, so our content objective for 4th grade, NF, numbers and operations fractions, B.3b. I can decompose a fraction into a sum of fractions with the same denominator. So remember, decomposing is breaking it up into its parts. We mainly focus on what adds together to create that. So we're going to break it down into parts that add up or have the sum of that fraction. I can use our language objective. I can use vocabulary related to fractions and addition to communicate how to decompose a fraction. Social objective, I can work with others to create models to prove the decomposition of a fraction. All right, so here we're going to show 5/9 in 5 different ways. So first, I'm going to break this down into 4/9 and 1/9, because I need to have a total of 5/9. So I'm going to color in 4 of these. 1, 2, 3, 4/9. I know the line is missing here. Sorry, it didn't copy well. And plus 1 more 9th. And that is 1, 2, 3, 4, 5 out of 9. So those are equivalent. If I break it down into 4/9 plus 1/9, there's 5/9. But I could also break it up into, let's say, 3/9 plus 2/9. Or commutative property of addition, I could do 1/9 plus 4/9 or 2/9 plus 3/9. So let's see, I'm going to do 3 of them here. Sorry, again, for some reason on all of these, this line right here did not copy well. So 3/9 plus 2/9. And I end up with 1, 2, 3, 4, 5 out of 9 filled in. But I could break it down in other ways as well. I could do 3/9, and I can break down that 2/9 into 1/9 plus 1/9. So I could have those 3/9 plus 1/9 plus 1/9. And I have 1, 2, 3, 4, 5/9 shaded in. I could also do, let's see, 2/9 plus 1/9 plus 2/9. Or commutative property of addition, I could go in a different order. Like here, I could have done 1/9 plus 3/9 plus 1/9, or the 1/9 first and then the 3/9. Same thing here. I could switch the order. That's that commutative property of addition. But I'm still looking at the same fractions. So I have 2/9 plus 1/9 plus 2/9 is still 5/9. If you notice on each of these, my denominator is always the same because that's how many total pieces there are. That never changes. The numerator changes because it's what's being represented. 2 of the 9ths, 1 of the 9ths, 2 of the 9ths, but there's still 9 pieces. 3 of the 9ths, 2 of the 9ths, 4 of the 9ths, 1 of the 9th. The denominator doesn't change because that just tells you how many total pieces in one whole. It's only the numerator that changes, how many are shaded in. We also have our decomposition with our unit fractions. 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9. 1, 2, 3, 4, 5 of them. So we have 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 still is a total of 1, 2, 3, 4, 5 ninths. So this is what decomposition is. It's breaking that down into the sum of its parts. And here we had 1, 2, 3, 4, 5 different ways to break it down. There are other ways that these could be written using the commutative property of addition, but basically these are the 5 we could do. Okay, so here we're going to just show 2 different ways, even though there may be more than what we're going to show. We're going to just show 2 of them. So here we're going to decompose 5/8. So I'm going to break it down into 1/8 plus 3/8. So that's 3 plus 1 is 4. I don't have enough, so I need 1 more. Plus 1/8. 1 piece plus 3 is 4, plus 1 more is 5. So as a model, what does this look like? I have 1/8 plus 3/8. So 3 of those pieces. Plus 1/8. Gives me 1, 2, 3, 4, 5 out of 8, 5/8. I could also break it down into, let's say, 2/8 plus 2/8 plus 1/8. Now I could have done 1/8 plus 1/8 plus 1/8 plus 1/8, you know, do the unit fractions, but these are the ones I'm going to do right now. Remember, there's more than one way to get there, to get to a decomposition. It's just whatever we need. So I have 2/8 plus 2/8 plus 1/8. And look, I have 5/8 again. So these two decompositions are equivalent. I end up with the same amount shaded in. All right, let's look at 5/6. So I'm going to break this one down into, let's say, 3/6 plus 1/6 plus 1/6. So I'm going to do 3/6, which is equivalent to 1/2. So half of this is going to get shaded in. And then my 1/6 plus my 1/6, and just one piece is missing to make the whole thing all 6/6. Just one missing piece for it to be whole. There's my 5/6. I could also do 2/6 plus 1/6 plus 2/6. That's another way I could break it down. So let's see, 2/6 plus 1/6 plus 2/6. Doesn't matter which colors you're using, just change off what you're using to show the different fractions. So 2/6 plus 1/6 plus 2/6 is still 5/6. So these decompositions are equivalent. They both equal 5/6. Okay, 8/10. Well, I could do 2/10 plus 2/10 plus 2/10 plus 2/10. So let's do 2/10 plus 2/10 plus 2 tenths plus 2 tenths. And that is 8/10. There are 2 pieces left over to make it full, to make it 10/10. But that there are 2, 4, 6, 8 pieces filled in out of a possibility of 10. Could also break it down into 3/10 plus 2/10 plus 3/10. There's lots of different ways we can decompose these fractions. I'm going to do 3/10 plus 2/10 plus 3/10. And again, we have 8 out of 10 filled in. So this is decomposition. When we break down a number or shape into its parts, the sum of its parts. All right, let's keep doing practice with part 2 and our 3-column notes.